We're going to look at a Radians question, which was from a C2 paper, CCEA C2 paper from June 2017, question 8. But it also comes up in the CA topic questions on Radians, and they've actually not got the right solution to this. They've put on a solution to a different question from that paper. So I just want to work through this one. It's one that I find tricky, I have to say. It's not an overly easy question. First bit of it is, and then the second bit is a wee bit tricky. It says you've got this shape here, you've got a triangle with a right angle there at A, and you've got a circle inscribed in this triangle. Your AB is 20 centimeters, so it's 20 centimeters here for your AB. Your AC is 16 centimeters. The first bit is very easy. It says find the exact length of BC. So BC is just the hypotenuse. So you just say BC squared then is just going to be 20 squared plus 16 squared. So BC squared just works out to be, let's just do this in the calculator very quickly, 20 squared plus 16 squared is 600. BC is 656, which means BC is a square root of 656. So BC works out to be, and that's 4 root of 41. Okay, so that's what they would want you to do. So if you put it in your calculator, square root of 656, you get 4 root 41. That is the exact answer. So there's your answer to part 1. So a nice easy start, and then the wheels fall off a wee bit in the next bit. Okay, it says, hence show that R is the radius of a circle is 5.19. So I'm going to get rid of these in a second. I'll put them back on it in some fashion in a bit. Okay, what we're going to do is we're going to draw a radius from here. So that's clearly R. We're also going to do a radius from here. And we're using our facts that we know about tangents. So we'll also do a radius down here. So the angle between a tangent and a radius is 90 degrees. And also we have got this is going to be a tangent kite. So this wee length from, I'll call this D here. So from B to D would be the same length, I'll call this E, as from B to E. And also this is a tangent kite, I'll give 3 lines for it. I'll call that F. So C to F would be the same length as D to E. So you can see you've formed a little kite like that. So that's why I will tie it up. It's a mess. So that's what you've got. You've got a tangent kite. And also you can see you've got right angles. So they're all going to be right angles here. Okay, right. So if this is R, if this bit here is R, then this is also going to be R. No, it doesn't look like it from my diagram. That's going to be R. Likewise, if this is R from here to here, this is a radius. This is going to be the same length. This is going to be R. So that means we can just zoom in on this, and we can say then, remember this whole bit from here to here was 20. So that means from B to E, just from B to E is going to be 20 minus R. Okay. And the same idea then, because they're the same length, that means 20 minus R is going to be equal to from B to E. So B to E was 20 minus R, B to D then, because they're the same, they're also going to be 20 minus R. Same idea. This whole length was equal to 16. So that was equal to 16, which means the length from C to F is going to be 16 minus R. And that means C to D, because it's the same, is also going to be 16 minus R. So we know that this whole length from B to C is 20 minus R plus 16 minus R, and that's also equal to the square root of 654. So we can just say the square root of 656, is equal to 20 minus R plus 16 minus R, and we'll just work with that. So when we tidy this up a little bit, you'll have square root of 656 is equal to 36 minus 2R. Bring the 2R across, switch the square root of 656 over, and then we'll just divide that all by 2. So just do that on your calculator, do 36 minus the square root of 656. Do it on my calculator and then divide by 2. That gives me an answer, and I'm just going to write this in. It's going to give me 18 minus 2 root of 41. And then hopefully when I press my SD button, it gives me 5.19. And that's going to be centimeters to 2 decimal places. And please tell me that's what I'm looking for. It was indeed. R is equal to 5.19. Okay, the last part of this question says, find in radians the angle ABC. So that's the angle here at B, basically. And you know the 3 sides of this triangle. So it's actually a cos rule question. I'm just going to draw a sketch of this then. So you had your B was here. This was 20. This was 16. And this was square root of 656. So I'll call this my theta. That's what I'm going to find. And that's what I want to find. And if you've got 3 sides in a triangle, this really is a GCSE maths question really now, you can use your cos rule. So the cos rule says a squared is equal to b squared plus c squared minus 2bc cos a, which could be rearranged to give you cos a is equal to b squared plus c squared minus a squared all divided by 2bc. So in our example here, the thing we're trying to find is our theta here. So theta is opposite to the 16. So that means if we say cos of theta, and then as well, sorry, I should have said, your A is opposite to your side A. So as long as you get that right, the A side then is 16, so it's 16 squared. Then the B, write them whatever way, it's going to be 20 squared plus, it's a square root, pardon me, square root of 656 squared, which is 656, and 2 times 20 times the square root of 656. I'm just doing this all in my calculator now to get my cos theta is equal to, so what was that? Fraction button, 20 squared plus 656 minus 16 squared, all divided by 2 times 20 times the square root of 656. And that worked out for me as 0.7808. 6 ago. Well, it goes on and on and on, but I just do the dot 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 to show you're using it in the calculator. Then cos till minus 1 of your answer, and I got my theta was equal to 0.67. I'll go for 3 decimal places, 67675, 0.675 radians, and that was the 3 decimal places. And that is it. Done.